I am Dr. Kay Stefanik, Assistant Director of the Iowa Nutrient Research Center. The purpose of the Researcher Directory is to highlight researchers working on nitrogen and phosphorus reduction in Iowa, and also allow anybody in the community, at the university, other agencies to be able to search for different nutrient reduction projects, as well as the researchers who have been heading those projects. The Researcher Directory has researchers from Iowa State University, University of Iowa, and University of Northern Iowa. In this video, you will hear from 4 researchers working on nutrient management, edge of field, land management, and multi-objective projects.
Hello, I'm Dan Anderson. I'm an associate professor in the Ag and Biosystems Engineering Department. The project that we worked on was exploring the use of manure and cover cropping strategies to try and perennialize our cropping production system. We really looked at a couple different cover cropping strategies, cereal rye, and then interseeding mixes of cover crops at about V4, and then a perennial system where we use Kentucky bluegrass. Overall, we saw a pretty good performance with the cover crop pretty consistently reducing nitrate leaching. But for the most part, our perennialized system where we use that Kentucky bluegrass performed well in that we got both yield pretty much the same as our control and did a nice job in allowing a system that only required us to plant once. The support was great, and we had a lot of learning to do during the last few years.
I'm Matthew Streeter. I am a soil scientist at the University of Iowa at the Iowa Geological Survey. I've been working with the Iowa Nutrient Research Center since really it was founded about a decade ago. We have lots of different exciting projects looking at edge of field and in-field conservation practices for water quality improvements. And a couple of the projects that we've been working on most recently are really well intertwined. We began working with saturated buffers and riparian zones, saw really great water quality benefits from those, nitrogen reduction. And now we have 2 active projects. One is looking at saturated grass waterways. So moving up into the field in those grass waterway environments where we still have a lot of organic matter, where we still have a lot of water moving. And we've got a project right now up by Rhinebeck in Iowa that's looking at the effectiveness of these saturated waterways for the water quality improvements. Along with those saturated buffers, as many people probably know, you can't put a saturated buffer in a waterway where you have standing tile inlets because they're prone to plug. We have another project where we're looking at modified blind inlets for water quality improvements, and you get probably a 90% reduction of sediment using these modified blind inlets. So we're looking at stacking these modified blind inlets in a catchment above a saturated waterway so that we can put or saturated riparian zone, so saturated buffer, so that we can put saturated buffers in catchments where inlets used to be. So these are a couple of really exciting things that we're doing with INRC right now.
My name's Laura Jackson. I'm the director of the Tallgrass Prairie Center at the University of Northern Iowa. Nutrient reduction can involve many different strategies, including installing strips of prairie on the edge of the field to reduce runoff, or by converting marginal ground to prairie. Native tallgrass prairie can provide the highest levels of biodiversity and a range of ecosystem services. So our research objective at the TPC is to learn how to increase the success and the reliability of prairie plantings for nutrient reduction. We basically want a prairie that can handle all kinds of soils, marginal ground, has several things in bloom throughout the growing season, and is able to resist weed invasion by being highly competitive. But it's not easy to achieve all of these co-benefits, and it takes a little more time and preparation. It's also not very familiar to most farmers. So our research is focused on keeping things practical and cost-effective. INRC funding has allowed us to answer several important questions, such as what's the best combination of grasses and forbs in the seed mix to optimize these important ecosystem services? What's the best time of year to plant? Is it cost-effective to mow the first year of establishment? Are the results of these studies, of these experiments, actually repeatable at different sites or years or cropping history? We've disseminated this research through peer-reviewed journal articles, field days, and winter meetings, our website, partners such as Pheasants Forever, and we enjoy collaborating with Prairie Strips Project at ISU.
Rick Cruz, professor in the Department of Agronomy and director of the Iowa Water Center. Much of what we do is associated with soil erosion and how farmers impact the soil and nutrients that are lost. One of the more important things I think we observed is that when ephemeral gullies form, that soil is exported, transported, typically out of the field farther than we typically see soil erosion from sheet and rill. Now, why is that important? When you have an ephemeral gully in the field, you fill it typically with tillage. What happens to that ephemeral gully location the next time a big storm comes? It's left open again. So how much are we losing? If you look at it on pounds per acre or tons per acre from the small area that farmers actually fill, we're looking at tens of tons per acre per filling event if subsequently followed by another rainstorm. So the key here, the takeaway message is grass waterways eliminate or minimize the formation of these gullies and therefore eliminate or minimize the need for moving typically nutrient-rich soil to these areas, which will then again be transported out of that area away from the field towards surface waters.
Thank you to all of the researchers working on nitrogen and phosphorus reductions with the Iowa Nutrient Research Center, and thank you all for watching.